If you've been trying to add an ESP32 in Tinkercad and you can't find it, you're not alone. In this video, I'm going to show you the best way to work around that limitation, so you can still plan your circuit, organize your wiring, and test your basic logic before moving your project to a real ESP32 setup. If this helps you out, make sure to hit like and subscribe for more simple tech tutorials. Let's get into it. First, it's important to know that Tinkercad does not currently support the ESP32 natively. In the component library, Tinkercad mainly focuses on boards like the Arduino Uno, Microbit, and ATtiny85. So if you search for ESP32 and nothing shows up, that's completely normal. Now, even though you can't directly place an ESP32 board inside Tinkercad, there are still two useful ways to work around this depending on what you need. The first method is best if your goal is wiring layout and project planning. Start by opening Tinkercad circuits and creating a new circuit. Then search for a breadboard in the Components panel and drag it onto the workspace. This gives you a clean base to build your layout. Next, if you want to represent the ESP32 visually, search for a dip support or use a generic integrated circuit shape. This won't function as a real ESP32, but it can help you organize the pin layout and keep your design neat. You can then place your wires around it as if you were building the actual project. To make this even more useful, use the Notes tool by pressing N. This is where you can manually label important ESP32 pins, such as GPIO2, EN, boot, or any other pin you plan to use in your real circuit. That way, even though Tinkercad is not simulating the ESP32 itself, you still get a clear visual map of how everything should be connected later. This method is especially helpful if you are documenting a project, teaching a class, or just trying to avoid wiring mistakes before moving to real hardware. The second method is better if you want to test the logic of your project. Since the ESP32 is not available, you can substitute it with an Arduino Uno. This is a very common workaround because many basic sensors and modules behave similarly in simulation. For example, components like the DHT11, PIR sensor, ultrasonic sensor, LEDs, buzzers, and simple switches can all be tested using the Uno. So if your goal is to check whether your sensor logic works, or whether your code responds correctly to input, the Arduino Uno is a great temporary stand-in. Build your circuit the same way you normally would. Connect your components, and then write your code in Tinkercad's code editor. Once you confirm the logic is working, you can copy that code into your real ESP32 project later. Just remember that when you move to a real ESP32, you will need to adjust the pin numbers because ESP32 pin mapping is different from Arduino Uno. That is one of the most important things to keep in mind. A pin that works in Tinkercad on the Uno may not match the same number on the ESP32, so always double-check your board's pinout before uploading the final code. If you are using libraries or sensor modules, you may also need to make a few small changes when moving from simulation to real hardware. That is completely normal, and it's part of the process when switching from Tinkercad planning to an ESP32 build. So, to quickly recap, Tinkercad does not directly include ESP32 support, but you can still use it in two smart ways. Use a breadboard and a generic IC or DIP-style placeholder if you want to plan your wiring and label your pins. Or use an Arduino Uno if you want to simulate your logic and test basic sensor behavior before transferring everything to your ESP32. This approach can save you a lot of time and help you avoid mistakes before you build the real circuit. If you found this tutorial useful, please give it a like, subscribe for more beginner-friendly tech guides, and leave a comment if you want a full ESP32 project walkthrough next. Thanks for watching, and I'll see you in the next one.